Hello, this is Project Lead the Way 3.1.7 Machine Control Design. The purpose of this video is to present what both Hannah and Joshua were able to complete in Mr. Sheely's POE class for this assignment. As a group, we chose problem number 2, and the problem is as follows. A surgical supplier needs a robotic arm to move equipment within a sterile environment. Your team has designed a remotely operated arm with 3 degrees of freedom. A base that pivots, arm that raises and lowers, and a pinch mechanism. Thus, we have the following requirements. A base that pivots, an arm that raises and lowers, and a pinch mechanism. Constraints: use as few motors as possible. The base should be able to rotate 360 degrees indefinitely in either direction. Avoid top-heavy building and make the project balance. The program needs to be neat and efficient and simple. The components that we need to be using, of course, would be the VEX claw mechanism and gears and wheels. We have some preliminary sketches that we started with before we started building. They included the idea to use a worm gear with a large gear and a big plate to use for the arm. To use a servo with a small gear to power the VEX claw. And a rotating base that rotated with a small gear attached to a motor around a fixed gear that attached to the bottom base. And then we also can explore the use of a sprocket and chain to power the lifting and lowering the arm instead of a worm gear. Now, here is an overview look at the actual project itself. Now, of course, we have about 3 to 4 different sections of the build itself. And what we can do is get the whole thing to turn about its axis. Here, actually, this way would be better. This is unpowered at the moment because we don't have the ability to power it here. But first to talk about would be the base with its wheels and this gearing system. So the motor powers it to a small gear, to a medium gear, and on the inside down in there, big gear that is fixed. These continue to move with the base, and they drive it around, and it's balanced on these 4 wheels all around the bottom side that guide it and give it a smooth ride. Next we have the arm here, which is on a chain and sprocket at the moment, and so 2 393 motors power this axle down in here, right here, and it powers this, and it allows it to raise and lower. And when the arm raises, we have a counterweight back here to help with the motors to make sure that they are able to lift the arm. And so as it goes up, the counterweight goes down, and the counterweight follows along this track so it never comes off course. And it's through some strings that are redirected by some shaft collar things here, and the string goes that way. And the claw mechanism is turned by another 393 so that it has at least 180 degrees of rotation here. And we have a claw mechanism here too, which is, as explained earlier, powered by a small gear with a servo, so it opens to a certain degree, but then never it comes back. And also with the base, there was a lot of weight on this one side from the center point, so we decided to put some ballast on this side to make it more balanced. Our coding is pretty simple. The only thing we have is some motors to program in. And so in port 1 we have the base motor, which powered those gears. Port 2 is the arm, which powers the chain and sprocket. Along with port 5, which we added in later, is arm 2, which is the second 393 motor that powers the arm. We have a wrist that powered the 393 motor that drove the wrist, and the hand, which is a 3-wire servo, which is the one that opens up the claw. Our program itself incorporates the use of the VexNet wireless controller. So we have code here that uses a special command which designates what button to use and what that button does. And so what we have at top is the while loop, which keeps everything going constantly. Then we assign the motor of the base to channel 4 of the controller, motor arm to channel 2 of the controller. And there's a difference between the worm gear setup and the chain and sprocket setup, which is only that the arm 2 is included in this, whereas it's not included there. Otherwise, each individual motor is set up for a different button so they don't get confused. In conclusion, the project was a success. At the time of recording, we have some coding issues, but those can be easily solved by us in little time. Concerning hardware, I feel we were quite ingenious with our design and kept very efficient with the space we used. The only place we really had issues was with how to power the lifting and lowering of the arm. It was either terrible sounding components, which many of our surrounding groups would agree with, or problems with providing the proper power to the chain and socket, which is why we have 2 different motors. But otherwise, a success, and I hope you guys enjoyed.